Everyone, my name is Hank Du, and I'm a senior software architect from Dynamic Computing Technology, or DCT for short. I'm very glad today to present how DCT platform and service can boost AI and HPC development. For this presentation, I will provide an overview of DCT Corporation first, and then we will provide an introduction of our AIon software platform and some service modules, including NGS for genome sequencing, MedicalAI for production-level medical service framework, HaiLabel for image data annotation, AutoML for assisted AI development, ADV Service for future information hub of mass electric and autonomous driving vehicle ecosystem, and more HPC showcase. Next, we will provide some success stories about the DCT service and sum up my talk. DCT was established in 2011 and is a subsidiary of Foxconn Technology Group. We have been dedicated in cloud system integration, cloud service, and neutral IDC. We launched the first commercial HPC in Taiwan in 2017. Our professional facility construction and management services, including air conditioning system, electricity and backup system, fire precautionary detection and prevention, environmental control system, and security system. DCT provides 24 hours by 365 days of operating service and has 99.95% of availability. Since 2016, we also hold NCC Type 2 telecommunication license, several ISO and CSA STAR certifications. We have been actively collaborating with domestic medical schools for HPC applications and service development. There are many types of DCT services for different types of customer and enterprise demands. For IDC infrastructure, we provide cloud server storage resource with virtual machines for flexible usage and deployment, or bare metal for maximum performance. For cloud application, we support containers, object or block storage, load balancing, multiple database and messaging functions, and virtual desktop. DCT also provides deployment support of enterprise SAP, including migration, upgrade, adoption, and maintenance. To secure customers' priceless data and communication, we provide anti-DDoS, web application firewall defense, and vulnerability scanning. Last but not least, we have AI and HPC service to provide assistance and value-adding tools to bring this HPC resource much closer and more accessible to our customer. So next, we will begin our introduction to our AIon platform for AI and HPC. From the infrastructure point of view, the DCT provides dedicated computing resource with CPU and GPU. We also have InfiniBand for distributed computing and NVLink for high-performance multi-GPU workload. Talking about cluster deployment, traditionally it takes some time for IT personnel to establish a cluster environment, including user management, network settings, and shared storage. Sometimes, even GPU drivers and additional toolkits are needed for high-performance computing. Big memory instances also available for special situations, such as large-scale database. We already know that these can be easily accessed or configured by some customers with sufficient understanding of their computing requirements. Now, the question is, how can we extend our service to broader population and customers who does not fully understand their computation needs, especially to those customers who are looking into digital transformation or AI-based solution development? To answer this question, we provide the AIon platform for smooth transformation in enterprise, medical, and research applications. We have NGS for high performance and high throughput genome sequencing with GPU support, MedicalAI with additional hardware and software features for fluent development and deployment of MedicalAI application, HaiLabel for image data annotation, AutoML for assisted model training in other service modules, or by user request during their model development. Based on AIon platform, we can easily build up many different types of application service. We have built a cloud service for data management and development of existing driving model, computer-aided diagnosis, and system deployment for medical facilities, industrial automated optical inspection, and we can easily apply these services and fulfill different enterprise needs. Through DCT AIon platform, we provide several advantages, such as faster deployment, especially with some cloud and edge integration and pipeline for model delivery, no-code solution, including AutoML and more assistant for model training, and it can save a lot of human trial efforts during model development, elastic deployment with different cloud service types, a neutral platform for compatibility among different cloud service providers, and unrivaled experience with more than a decade of server design and manufacturing, ready for more consulting and deployment service. Now, let's begin with the NGS platform for genome sequencing. The platform accepts data from primary analysis hardware in medical facilities and performs alignment, preprocessing, and variant calling. For CPU-based analysis, our cluster system can accelerate the NGS analysis from 3 days to about 35 minutes. Now, our NGS system provides GPU-based acceleration capability. With multiple GPUs, we can achieve high performance and high throughput for batch analysis. In our benchmark of germline analysis with a standard test case, the overall computation time of the germline pipeline can be accelerated to be completed in about 1 hour, which is over 50 times of speed up to CPU-based analysis. Next is our MedicalAI framework. During our engagement with many medical facilities, we have learned that physicians and radiologists take a lot of time and effort on X-ray image diagnosis. X-ray imaging is one of the lower cost, faster, and more popular approach for medical imaging, and it is used for early diagnosis of various diseases. With its popularity, we can expect tremendous amount of X-ray images for diagnosis. To ease up physician and radiologist efforts, we develop MedicalAI models for assisted diagnosis and use GPU system for enhanced service response. With our MedicalAI system, we have achieved the following service capability of unchecked X-ray application. First, we can get 250,000 images analyzed in 1 day. For single case inference, it only takes 1 second to complete one single AI assistant response. And overall, 95% of analysis cost savings compared with traditional human-only workload. When combined with other AIon service, our goal is to invite radiologists and physicians to join the AI development pipeline. We believe that MedicalAI models should be constantly refined, especially when new image protocol and equipment are established. We also understand that we need new annotated data set to optimize smart machine learning models. Our service can help streamline the whole process. In the end, the new model can be updated as a new servable asset to enhance quality of assisted diagnosis. The benefit is not simply for image prediction only. It can also be used in clinical environment, triage, or some similar application scenario. To deploy AI solution in a medical facility, we need to design a framework for smooth adoption in medical facility and simultaneously reduce learning curve of medical personnel. Our MedicalAI solution provides an on-site edge AI server for low latency model serving and integration to on-site IT systems such as PACS. And our client can easily manage their models and data through web user interface and data management system. The edge server can also communicate to our MedicalAI cloud for model update. Note that model training is an intensive computation task, and we need high-power GPU in HPC cloud for heavy lifting tasks. The data management function also assists the process of dataset and model synchronization. In addition, core model management and annotation modules are available to establish a complete AI development pipeline. Throughout this pipeline, our customer can enjoy many advantages of MedicalAI framework. First, now it is easy to execute continuous model optimization. Second, model update and deployment is also easy now, and model serving is closer to the application site for better response time. Third, our monthly service subscription model is cost efficient. And finally, our customer can easily access our model development platform for free control of their own data and model assets. In summary, the MedicalAI framework aims to make AI deployment fast and smooth, reduce impact and disruption of medical operation. Meanwhile, we provide access for radiologists and doctors to the model development process, such as annotation. We always listen to professional idea on how to build AI systems to truly resolve issues, including which objective to accomplish, how pipelines should be designed, and how to integrate them to a clinical environment. A marketplace can then be established for future use, including dataset, models, deployment methodology. Moreover, our annotation service comes with AI assistance, and professional feedback can also act as an optimization data source to enhance future assistance capability. Talking about annotation, we have HaiLabel for image data labeling service. It supports image classification, box type object detection, and instance segmentation. It is available as a cloud service on AIon platform and can be connected with dataset storage, model management for better integration of deep learning pipeline. In general, collection of annotated dataset is the most time-consuming and demanding to human labor. If a pre-trained model is available, HaiLabel can send image data to the model for label results, and annotators can fix the results instead of starting everything from scratch. For the most arduous stage of AI development, HaiLabel assisted annotation can significantly improve the process, which will be explained soon. For some special purpose application, we understand that some pre-trained models comes with customized design and inference procedure. Custom pre-trained model support can be added by request so that it can be a part of assistance model. When combined with the AIon model service, we can build up an iterative procedure of training dataset collection and model training. Very helpful when dealing with massive unlabeled dataset for high quality model. We also tested some examples and see how much time we can save for annotation. In these videos, we compared completely manual labeling with assisted labeling. The annotation type is instance segmentation, and we need to plot a contour polygon around an object. Note that this video playback are 2 times speed up. With manual annotation, it takes more than 2 minutes to label 3 cars, while refinement from inference results of pre-trained model only takes less than half of that time to complete. It takes little time for model inference. In our benchmark of other cases, we can easily get 2 to 10 times of speed up of box or polygon labeling. The feature not only saves annotation time, but also reduces fatigue of annotators. This is very important when working on professional AI projects such as medical and industrial ones, because professional annotators of these fields are very hard to employ for these tasks. And it is imperative to do anything necessary to reduce the labor cost. Here is one of the high-level examples during medical application engagement. In AIon platform, we define which type of model should be developed and select pneumonia X-ray models from platform marketplace. Multiple models may be selected to provide additional report and inference information when needed. For an object detection model, we start from a model based on open data set and use it as a pre-trained model for assisted annotation. Doctors can then refine the detection boxes instead of doing everything from scratch. Next, the AIon platform collects the annotated dataset and retrain the model. Or AI engineers can develop a new model architecture based on characteristics of annotated dataset for better training efficiency and model quality. We can repeat the similar process when new image data are collected for new model optimization and keep the on-site model updated through MedicalAI-Edge system. We also apply HaiLabel to industrial applications such as automated optical inspection on printed circuit board. This is a collaboration project of Foxconn Industrial Internet, and AIon provides AI and HPC system for the internal service. The concept is on top of model pipeline feature already available in AIon platform and the iterative retraining and annotation process, while we have additional support on image classification. More streamlined retraining process for user. Assisted annotation is once again introduced to utilize our high-quality model by the data analysis group. The process can easily optimize AOI models to better adapt new inspection batches and fulfill more automation of manufacturing. Next, when we move to AI model training, we still have some training steps to go, such as model hyperparameters. Usually, the parameter tuning is a trial and error process to achieve better accuracy in future application. And it depends on a lot of factors such as dataset characteristics and relations between specific parameters and options. Professional AI scientists can devise a better trial, but it still takes some trial process by themselves. Some end users do not fully understand the process, and we present AutoML to guide the user through this process. The user can simply designate scanning domains and options, and the AutoML will handle the rest. User can also request more computation resource by adding task concurrency for faster scans. When the tuning process completes, the user can access the results with visualization and detail list, including combination of parameters, metrics, execution time, and so on. The information also provides some reference about reasonable parameter range. In this way, the user may not need to go through the whole process again for similar dataset and computation. For example, if some options can be predetermined, the scanning domains can be narrowed down in future runs, and this can usually give better efficiency to the tuning process. Here is an example of the AutoML use case, which is a chest X-ray classification model. The figure here shows comparison between one hand-tuned Visual Transformer 16 model and AutoML models with 3 different types of architectures. You can see there is not much difference between them. Overall, the hand-tuned model performs slightly better in many categories, but it needs a professional AI scientist to achieve such result. For AutoML models, the user can simply send the most basic setting to AutoML and the HPC system will handle the rest. In the end, you can get a very close performance. So next, we will take a look into the ADV platform. Recently, the DCT also joins the MIH Alliance to support cloud platform development of electric and ADAS or AD vehicle and related IT service. We understand that there are many different types of services for autonomous electric vehicles such as electricity, autonomous driving algorithms, security, mapping, and deployment. We need an open service and communication platform to integrate them together. With this integrated ADV platform solution, we can help our customer to deliver new vehicle features in an easier, faster, and more reliable way. For electric vehicle startup, this platform provides a shortcut to the development ecosystem without building connection and service components from scratch. Basically, our ADV solutions help vehicle vendors to accelerate their time to market. This figure illustrates our concept of autonomous driving upgrade on our platform. To enhance an ADAS or autonomous driving model, the first step is to collect driving record data under agreement and authorization of end users. The data will be our dataset for ADAS or autonomous driving model training, which will go through a development pipeline including data annotation, verification, training, and simulation. When training is completed, the new model will be packaged as a service upgrade and ready to release, and it can be distributed through third-party solutions with optional security subscription and regional check. As an open service, our system can be deployed on Foxconn, Mount J Cloud, Microsoft Azure, AWS, and Google Cloud. Based on the AIon ADV solution, we are integrating more and more solutions for more service features. Starting from the fundamental electric vehicle system and autonomous driving stack, we are building collaboration over mapping service, vehicle-to-grid, blockchain, over-the-air delivery, vehicle-to-everything, and telematics. All these functions will be deployed on multiple cloud service providers. Under the MIH Alliance, our ADV solution is the fastest way for any customers and vehicle manufacturers to join the ecosystem. Last but not least, we are also open for collaboration on computation service with different type of AI or HPC workload and software components. For example, some bioinformatic application involves molecular dynamic simulation, which is one of the most challenging and demanding tasks right now, especially with the current COVID-19 situation. Before simulation of dynamic behavior, the protein structure must be determined either by computer simulation or experimental analysis. Since experimental analysis is very expensive and time-consuming, there is active research on how to predict protein structure simply from a protein sequence, which is another huge challenge. There is also a community called Critical Assessment of Protein Structure Prediction, or CASP for short, aiming to address this challenge. Recently, AlphaFold by DeepMind is considered one of the major breakthroughs in this field. This function is to predict protein folding structure based on its sequence only. The process involves different computation stages with mixed CPU and GPU workload. This is an example of AlphaFold 2 prediction of T1050 protein from CASP14 dataset. The next example is molecular dynamics simulation such as nanoscale molecular dynamics or NAMD. NAMD is one of the most popular tools for simulation of large biomolecular systems, and recently it won 2020 Golden Bell Prize for its role in COVID-19 research. We can easily get more than 23 times of speed up over 8-core CPU virtual machine. Now, if we connect different computation components with our infrastructure and platform, you can see an application pipeline for biomolecular research is taking shape. This case is a seismic wave simulation test based on an open package SpecBeam 3D Cartesian. It is also another showcase of multi-GPU acceleration. Here is an example of Mount St. Helens simulation domain. The simulation is set for 100 seconds of propagation time, and we get more than 140 times of speed up with 4 GPUs over 4 CPU cores. Also, it takes about 8 seconds to complete 100 real-world seconds of prediction, which means that when a seismic activity is detected with determination of source pattern and location, we can launch a simulation to predict or at least catch up the wave prediction, get an early shake map like the lower left figure to assess hazards such as landslide, and potentially create more advanced seismic warning system. On the other hand, it is possible to establish a joint simulation mechanism, an iterative optimization pipeline for enhanced geophysical analysis and future prediction accuracy. The process takes much more computation resource to complete, and this is another topic our GPU infrastructure does best. With our HPC infrastructure and platform service, we hope to establish more collaboration with public research and service. Next, we will take a look into our recent success stories. For MedicalAI, let's take a look into more detail on collaboration with Kaohsiung Municipal Xiaogang Hospital. For many years, emergency service in Xiaogang Hospital had been overloaded due to close proximity of several public service sites. Such a congestion can lead to long wait times for patients. When the COVID-19 pandemic begins, there is even more demand for quick diagnosis since there is an international airport nearby. Basically, an assistance solution must be provided and deployed as soon as possible to address these issues. Besides, the deployment should not be disruptive to daily operation. With the MedicalAI from DCT, a chest X-ray assisted diagnosis solution is developed. Edge assistance systems with GPUs are also deployed for faster response of model inference. The overall benefits are 20 times speed up of interpretation workload, and more importantly, significant improvement on human workload for better service quality. This page shows our engagement in detail with Xiaogang Hospital and demonstrates why AIon is so critical to our success. In some medical AI research, public dataset is selected for model training. The problem is public dataset either varies too much, needs a lot of data cleaning effort, or shows unmatched characteristics to those of practical dataset. Since the inspection protocol and device are different among facilities with limited data volume, it is more feasible to build a local dataset for better representation of inspection type characteristics in the target site. It is also easier to achieve inference accuracy demand and faster to deliver our service. In the left figure, you can see some accuracy dip due to mismatched dataset characteristics. Once we will apply the new annotated dataset by radiologists and physicians in Xiaogang Hospital, we get significant improvement to several models, and we keep improving model architectures. Recently, the pneumonia classification achieved over 90% of accuracy for the Xiaogang Hospital dataset. Anomaly detection model also shows significant improvement. These models are updated to on-site edge systems to improve overall service quality. We also have additional functions such as continuous monitoring tool for patient medical image tracking and connection to on-site picture archiving and communication system. The right photo is the DCT software lead, Hector Yang, demonstrating the MedicalAI system. He is also the designer of the whole AIon platform and edge ecosystem. We also have collaboration with the Heart Institute in São Paulo. In 2019, we deployed a M100 HPC rack system to support more advanced medical research. The single rack system has all HPC components available to support different computation workload, such as CPU, GPU, shared storage, high-speed network for cluster computing, and additional management stack for easier IT operation, maintenance, and monitoring. This system is a significant boost to the research team. In research projects such as cardiac left ventricle segmentation from cine MRI and chest X-ray classification, our rack system delivers 60 times of speed up compared to their early GPU system. More publications of their research are conducted and computed on our system. So we hope in our presentation, this DCT platform and service introduction provides some showcase and inspiration to everyone building AI and HPC. We're also looking forward for more collaboration with experts from different domains to push for a wider spectrum of our services. This concludes my talk today, so thank you for listening.